let's get on to an application of integration, of the complex integration that we've been doing. And this is volumes of solids of revolution. So, what we've been doing in methods, right, is we've been finding the area underneath a curve or the area in between two curves, right? What we can do in specialist is we can actually consider if we had a curve, say a parabola in this domain here. Not sure why it's so thick, but it is. If we had a parabola, instead of just finding the area underneath this curve, what we can actually consider is, well, what would happen if we rotated this around the y-axis? What would happen? We would kind of be left with like a bowl shape, right? Like this. But it's of course all shaded in. So if we rotated this around the y-axis, we'd be kind of left with a bowl shape. So what we can say is, well, if you have a bowl kind of in the shape of this parabola, we can find the exact volume of that bowl using these formulas. And this is a really cool concept, right? Because if you even have like if you have some kind of circle here, we can rotate this around the x-axis, and that could find us the volume inside kind of a sphere formed by this circle. So it has a lot of these really cool practical real life applications, especially if you maybe like are constructing something or something like that, and you have kind of made this construction based off of a function. You can find the area within that. That's really cool to me. Like a nerd, but like, I don't know, that's awesome. Anyway, so what we can do to actually find the volumes of solids of revolution is apply these two formulas here. And these are in your formula sheet, so don't stress about remembering them. But the volume rotated around the x-axis is going to be the definite integral of pi multiplied by the function y with respect to x. So by the function y, I just mean like, if your function is like y equals x plus 2, you just have x plus 2 in there. But of course, if it's rotated around the y-axis, we need to integrate with respect to y. So our function needs to be in terms of like x equals blah, 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 y, blah, 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 y. So our function needs to be in terms of y. So a and b in both of these limits are the 2 points in which we are calculating the volume. So if we are rotating around the x-axis, these two limits need to be x coordinates. And if we are rotating around the y-axis, these two limits need to be y coordinates. Now, the big tip that I have here in all caps is check if it's rotated around the x or y axis. I swear, this is a thing that I would always make the mistake of. Maybe you guys are smarter than me. I would always mess it up and say that it was rotated around the wrong axis just because I wouldn't read the question fully. I just kind of like, I was a little bit arrogant. I just like assumed that I knew what was going on. I just didn't read the question. Didn't think I needed to. So, when you don't check if it's rotated around the x or y axis, you're going to use the wrong formula and you're going to use the wrong limits, and then you're going to get the whole question wrong. So, check what axis it's rotated around. The question will tell you which axis it's rotated around, and then make sure that you're using the right formula and make sure that your limits are right. If it's rotated around the x-axis, your limits need to be x coordinates. If it's rotated on the y-axis, your limits need to be y coordinates. Make sure you've got it all down before you even attempt the question. Especially if the question just says like rotate on the x-axis, like circle it in your pen or something. I don't know. Maybe it's just me. I just always made that mistake. Okay. And then a tip, if you have a symmetrical function, you can kind of cut it up so that one of your limits is 0, which kind of makes the whole process easier. So an example of this, which I have written in words down below, is if you have like something like this. You have a sphere, and you want to rotate her around the y-axis. Rotate, y-axis. What you can do to make it a little bit easier for yourself is just kind of say, well, I'm going to rotate this top part around the y-axis, but I'm not going to consider this bottom part, and my limits are going to be this value here, the y-intercept, and 0. And then your volume is going to be 2 times whatever else. The reason that this is easier is because then one of your limits is 0, which is often easier to kind of sub into values, as opposed to like whatever this value is down here. Maybe it's like b, the other intercept. Of course, this only works if the whatever shape you're working with is like centered on the origin. So of course, actually, that's going to be negative a. So of course, you're finding this volume here by only rotating around this part on top of the x-axis, and by choosing your limits 0 and a. And then when you're actually calculating your volume, you need to make sure that you include multiplied by 2, because of course these two areas are going to be the same. Sorry, these two volumes are going to be the same, so you just need to multiply by 2. Okay, now let's get on to an example. So, if we are rotating y equals root x plus 6 around the x-axis from negative 6 to 0. So, firstly, check. Which axis is it rotated around? X. So, what we can do is our volume. Our limits are going to be negative 6 and 0, and these are given to us in x values, which is what we want. We can take this pi out the front, and then in here we're going to have the function in terms of x squared dx. So we just applied our formula here. This is really useful because now those two squares cancel out, which just leaves us with the definite integral of x plus 6, which is super simple. So we are just going to get half x squared plus 6x between 0 and negative 6. So is this, of course, going to be equal to the negative of a half times 36 plus negative 36, which is going to be equal to a half of 36, which is going to be 18, negative 18, I believe, positive 18, sorry, because we had this negative out here. Okay, so this gives us an answer of 18 units cubed. Make sure you write units cubed at the end, otherwise you might lose marks. Okay, now we are going to get on to our next topic,